All right, welcome to chapter 19, where we'll cover transformers real quick. So, transformers are used to transmit AC, right? One of the benefits of AC is that we can transmit over long distances, and the transformer is the device that allows the ratio of the voltage and the current to remain the same, but we can modify. So we can have high voltage on one side, low current, and then transmit it with low voltage and high current, or vice versa. All right, so that's one of the benefits of AC. Now, the transformer is the device that does that. So it transfers electrical energy from one circuit to another with no physical connection, and it does it through the process of induction, right, which is what we saw last week. So the mutual induction involves that, and because the AC is alternating, right, that it's going positive, negative, that motion is what produces the induction. So it's very, very important that we understand that. Now remember, power equals current times voltage. And if we have 2 amps times 10 volts, that's 2 watts, or 20 watts. Same as if we have 1 amp at 20 volts, it's still 20 watts. So if we can change the ratio 2 to 1, stepped up or stepped down, then the power is still going to be the same. And then when we transmit it, that has the benefit of helping us there. Now, some of these slides I'm going to go over fairly quickly. So the primary coil here, which is assumed to be 120 volts, and depending on the number of windings or turns in the primary, the voltage on the primary divided by the voltage in the secondary will equal the ratio between the turns on the primary divided by the turns on the secondary. So that is going to get us to, and you can read all those slides I'm skipping, but it will get us to this formula here where the NP equals NP over NS equals the voltage in the primary over VS. So in this week's homework, there will be a bunch of problems where you'll be giving one of these or the other. So let's say we know it's 100 to 10, and we don't know what VP is, but we know the secondary voltage is 25 volts. We can solve this by saying 100 divided by 10 is 10 times 25 is going to equal VP, which will then equal 250. So the voltage in the primary, if it's a 10 to 1 ratio, the voltage has to be a 10 to 1 ratio too. So you can solve this by doing the division first, multiplying times 25, and you'll get that. So there's several homework problems that have this same kind of concept on it. So if you're given, say, a ratio, and the ratio is always going to be the NP and S. So if it's 8 to 1, that means NP and S equals 8 to 1. And then if let's say we're also giving the VP equals 30, so this is going to equal 30 over VS, so 8 is going to equal 30 over VS. So if we just cross multiply and divide, VS is going to equal 30 divided by 8, which, what is that? 3.75 volts or whatever it is. You can divide that out and calculate it. But it's all about ratios. So with these transformer problems, and for the homework, I really want to make sure that you write down the formula. So show me what formula you're starting with. And one thing I notice in the textbook is that sometimes the text is going to show, so here's a transformer is 200 turns in the primary, 50 turns in the secondary, and 120 volts applied to the primary. What is the secondary voltage? So on that one, you can, so like the textbook shows it all this, but what I would like to see is start with NP over NS equals VP over VS, and then cross multiply and divide, or do solve for your unknown and then do it. This just kind of starts with, well, VS equals VP times NS over NP, and you're like, where did he get that? Well, it came from this formula here. So always start with this equation 19.1 and then work your way to wherever you're going. Okay, so there's 400 turns, primary turns in a transformer. How many turns must be wound on the secondary? So again, if you solve, you'll get 80 turns. And then determine the amount of secondary voltage when the primary voltage is 10 volts AC. There are 100 turns in the primary and 1,000 turns on the secondary. So that's a 1 to 10 ratio. So you can calculate that, and then the same thing there. All right, so there's also some of these concepts of step up, step down. A step down means that the voltage across the primary is greater than the voltage across secondary. So steps down, and then the opposite is a step up. All right, so you can look at those. And again, here, if it's just listed as a ratio, that's saying NP is 7, NS is 1. And then if you know the voltage on the secondary, you can calculate for the voltage on the primary. So it's just 7 times more, and away you go. All right, so here's this one. And then the other concept here is the ampere turns. And this is where you see this IP NP equals ISNS. And you'll need that formula for some other homework problems as well this week. So IS equals IP times NP over NS. So they just took this equation and solved it for what they're looking for. But if you start here, you can always get it. And that's that. And then here's where it shows that one. Was the turn ratio when IP equals 1 amp and IS equals 5 amps. And then again, just the ratios again. And then there's some slides in here that go through transformer loss, copper loss. I'm going to leave these slides for you to read. They're right out of the textbook. So if you have the textbook, just read chapter 19 as well. And then here's some of the symbols for an air core transformer and an iron core transformer, just like with the magnetism and the inductors. Here's showing the polarity. So the dots represent where the polarity is. And in this case, the blue dots on the left show the negative polarity, and then the blue dots on the right show the positive polarity. And some more symbols, some basic information. The last thing I want to talk about here is the the impedance matching. So remember in DC, we wanted to make sure that the resistance of the source needs to match the resistance of the load. So in AC, that resistance is referred to as impedance, or Z. And we're going to come back to that in much more detail in chapter 23. But the impedance has to match. So in order for that to be true, the ZP, or the impedance of the primary, divided by the impedance of the secondary, equals the number of turns in the primary divided by the number of turns in the secondary squared. So you're going to see some problems where they'll solve for ZP, and then here's if you take the square root of both sides, NP over NS equals the square root of ZP over ZS, right? If you come back here, you square both sides, or take the square root of both sides, and NP and S equals that. So it's just some basic algebra to solve, to get these in the right way. So here it's saying determine the required ratio. So here the impedance 800 divided by 8, so that's 100 to 1. And you can see that if you take the square root of 100, it's 10, and that's how you get the number of turns. The ratio is 10 to 1. Okay? So that's really chapter 19 in a nutshell, and you can you should be able to do all the problems in homework 6 when you pick that up this week. And again, you'll turn this in at the end of, or in the beginning of lab 7 next week. All right, that should get you where you want to be, and I will talk to you later. Bye.